Welcome. Today we'll be carrying out molecular docking, and instead of just discussing about molecular docking, we'll be performing an actual experiment using PyRx and Discovery Studio. In the past, I've introduced molecular docking. I've also introduced PyRx, and I've told us some of the advantages of molecular docking. But today we're going to carry out a practical. Now, I think that helps a lot instead of just talking about it. Now, so the first thing to do is to download the target receptor. That's the first thing you should do. And that depends on the disease you are working with and what are you expected to do as a researcher. The best thing to do is to consult literature and look at works that have been done in that direction. Then when you search through literature, you will get the protein that you would work with. Now, the website for downloading the target receptor is www.rcsb.org. Go there. Now, for today's work, we are going to be using a target protein. We are working on anti-diabetic related research. So we are working on diabetes and we'll be using the phosphorylated insulin receptor tyrosine kinase as our protein target. Now, how did I come about that? I went through literature. Now, the compounds we'll also be working with will be downloading are curcumin, berberine, rutin, cartartin, and quercetin. And the standard drugs will also use are metformin and rosiglitazone. Now, why did I choose this receptor or this target protein? Now, let me take you to literature. Now, this is a research work on molecular docking analysis of candidate compounds derived from medicinal plants. And if you go through it, while going through it, I saw different receptors. And after reading through it, I chose to work with the receptor 1IR3, that is the kinase we saw. So that's what I'll be using. So what you do is look at this code. This is a PDB code, and then that's what you would be using to download that particular target protein. So let's go to rcsb.org. You can see that. Now don't forget the code name. It is I1R3. So I'm sorry, I think it's 1IR3, 1IR3. Now you can see this. Now, why are we choosing this receptor? This phosphorylated insulin receptor tyrosine kinase is a very important receptor. And then what it helps to do is that it keeps the insulin receptor active, and that improves glucose intake. Especially for type 2 diabetes mellitus, the issue is that there is insulin resistance and there's low glucose intake. So by modulating the activity of this particular enzyme, it means that there will be more glucose intake, and then that will deal with that condition. So that's what we are working with. Whatever compound we are docking with, we are trying to see if that compound can modulate the activity of this receptor. By doing this, it makes the insulin receptor active, and then it improves glucose intake and reduces insulin resistance. This is very key. So let's download. So when you want to download, you download the PDB format. So I've downloaded it. Now let's go down and let's go through our target protein. You will discover something. You can see that we have different, okay, we have a single chain, chain A, and some would have, okay, we also have chain E, chain C, okay, and other chains. Now, there are important things you also need to know, and that is when it comes to small molecules, we are looking at this ligand. Please look at the ligand there. It is ANP. This ligand is very key in choosing the coordination site. So it's important you um, note this ligand because we will see this ligand when we import our protein in Discovery Studio. So let's download this file. We'll be downloading the Mol2 format for that ligand. That ligand is called the co-crystallized ligand. So let's download it. Okay, so that's also good. So we've downloaded the target protein and the co-crystallized ligand. Now, once you're done doing that, now the next thing is to download our compounds. So let's download our compounds. We're going to be downloading curcumin, berberine, rutin, cataratin, and quercetin. And how do we do that? We use the PubChem site. It's a database for compounds. So let's use that. So let's start with curcumin. So go to PubChem, just type curcumin PubChem. I think sometimes I like doing it like this. So click on this, it brings it out, it will take you to the site. Now you can see this web page contains information on curcumin. So click on download and then you download the 3D conformer, download the STF file. Now this is for curcumin. Now don't forget the ID for curcumin is 969516. So choose to save it somewhere. Let's save it in a notepad. Okay, so curcumin. So our ID, sorry, ID is this. Now the next thing is berberine. So click on this and download berberine. So this is what you intend to work with. So click on it too. And then you go to this and then you download the 3D conformer. Now for this, berberine is okay. So let's copy this, I think. Better this way. Okay. Now the next thing is routine. Routine. Now some of us have worked with these compounds. They are natural, they are compounds gotten from nature, from plants. So we'll download. Okay, and that is routine. So routine, Control C, and then let's see if this is so good. Now then we have cartaratine. Good. And then lastly we have quercetin. So I want to save this so when we are done docking we don't forget what we worked with. And then finally we have the commonly known quercetin. So let's download. Good. Also, this is quercetin. You see, so we've downloaded curcumin, berberine, rutin, cataratin, and quercetin. Now we also have, like I showed us, we also have standard drugs like metformin and rosglitazone. So let's download metformin. So metformin. Okay, so let's take the information. Then rosglitazone. Rosglitazone. So download rosglitazone. Let's get the PubChem information. So we have downloaded everything. And I would like to create a folder that contains everything. So let's create a folder to house all this. So we'll call that folder molecular docking anti-diabetic research. Now you can choose it to name it whatever you wish. So let's copy everything there. Oh, sorry. Okay, good. So we have everything in this folder. Now, when you're done downloading your ligands, which is what we did, now it's also important to recognize that is you can also get your compounds by drawing them yourself. You can use ChemDraw and then change them to 3D using the Chem 3D, or you can use Avogadro. You can also download them from other databases like ChemSpider and many other things. So use what you have, what you can easily access. But I think PubChem is accessible, and once you are using PubChem, you are most likely going to get all of the compounds you intend to work with. Now, the next thing is to obtain the coordinates for your binding site. Obtain the coordinates for your binding site. And how do we do this? Now, we use Discovery Studio. So I'll be opening Discovery Studio. So click on Discovery Studio. Now, we've been able to open Discovery Studio. So what you do is go to New and click on Molecule window. Now, what we intend to do at this point is to obtain the binding site. Please don't forget that. What we intend to do is to obtain the binding site, the binding site, the binding site. So let's go and then let's import our target protein. And that is, don't forget, that is so this is it. Now once you import it, you have something like this, and then this is the structure of the target protein. You can see water. These are water molecules with red dots, and then you can see the protein strands, and you can even see the co-crystallized ligands. Now let's open this a bit. Now the co-crystallized ligand, if you remember, was um, let's go back to it. That's AMP. So we are going to look for it here. Now, okay, now you can see ANP here. So this is AMP. So what you do is right click and then click on attribute of AMP 300. Now this is good. Now you will see something with XYZ. You will see a particular line XYZ, and that's what contains the coordinates. So we click on it and then you can copy it because that's the coordinate you'll be working with. So let's have it here. So this means that X is this, Y is this, and Z. As you can see that. So these are the coordinates X, Y, Z. And how did we obtain the coordinates? We used the co-crystallized ligand. And that's why I said that it's important you understand and you identify the co-crystallized ligand. It will help you a lot to know the correct binding site you would be working with. Now, the other thing you intend to do is to make sure that let's close this. Now, you don't want to dock having the co-crystallized ligand still there. You don't want to do that. A lot of times when we dock, we remove all of the ligands. We remove water and we remove the ligand. So what I'll be doing is I'll remove water. So I'll go to remove group or cut. You can choose to cut. Good. Now the next thing we intend to remove is the ligand. This is the ligand we intend to remove. And if there are other ions that are present, I think, let's see if there are other ions. Okay, so we have magnesium, so we'll be removing magnesium ion. The goal is that when you are docking, you are trying to make sure that you are mimicking that protein in its natural state. So you're going to be removing everything that's not supposed to be there. So let's remove magnesium. Let's cut it. We will also be removing ANP, the co-crystallized ligand. Now, and then we'll be removing this. Good. Now, I think we have one extra ligand that's remaining. So, we also do not want to have this. I think this is another ligand, but let's see. Okay, so we have a second ligand, so we don't want any ligands in there. So we're going to remove everything. So let's take this ligand out. Good. So we just have the protein groups. So what we do is we go to save as, and you would save this molecule as a PDB file. But let's call it, this is I1R3 now without that's what I want to call it, without water and without ligand. Now, so you can save it. So it's important you remove all of the ligands and then all of the water molecules because they would affect your docking and they might even give you wrong results. Now, after you've done that, um, we've pasted the coordinates on the notepad. You can also choose to write it. The next thing you want to do is to remove the co-crystallized ligand and water, and then we've done that. I showed you how to do that, and it's very important you remove it. If you leave the co-crystallized ligand and the water molecules, it affects your result. Now, The next thing is to import your ligand and protein target into PyRx. So let's see how we do that. And to do that, we'll be using PyRx. Now I'm taking this step by step because I want every one of us to be able to do the same. If you encounter any issue while doing this work, please, you can always get across to me. So we are opening PyRx. We've clicked on it. So let's wait for PyRx to come up. Now, once you've opened PyRx, this is PyRx, the first thing you want to do is that you want to import your molecules. But before you import your molecules, it's important. Okay, let's click on load molecule. So go to downloads, and then the first thing I will import is my protein target. Good. Now the next thing to import will be the compounds we have there. Let's see all files. Now you can see that we have different conformers and they come in an SDF format. We cannot import them like that. So what we do is that we use the Babel function to load the structure, to load SDF structures. So let's do that. So navigate to that folder, and then it doesn't allow us to select all of them at the same time, so we just import it one by one. So let's import this. Good. Now we also load the second one. No, sorry, not load. Use the Babel function for this. Then the Babel function for the third. For the fourth. With 1, 2, 3, 4. Okay, for the fifth. For the sixth. And then lastly, I guess for the seventh. Now we also have the co-crystallized ligand, so we can choose. Let me see if we can load it using Babel. If not, we will go back there and okay, I don't think it will allow us to do that. Oh, I think it did. Now, so what do we do? Now you've imported all of these structures using Babel. So the next thing we will do is to minimize the molecules. And the reason why we have to do that is because the structure of these molecules are not minimized. And it means they are not representative of how these structures exist in nature. Often, when we are doing docking or modeling, we often use the equilibrium conformer, that is the conformer with the lowest energy. So we will minimize these structures. If you don't minimize, your result will be wrong, and I can tell you that for free. The result will be wrong. So let's minimize our structures. So we want to minimize using any of this. So Okay, I think it has to be done one by one. So okay, let's minimize all. I think that's it. So we minimize everything. Oh, that's beautiful. So we have minimized everything. And how did I do that? Just click on it and then right click and go to minimize all. Now the next thing you want to convert all of them is to convert all to autodoc ligand PDBQT. So convert all selected to autodoc ligand PDBQT. So we are converting all of those compounds to PDBQT. Now, so we've done that. Don't let this dialog box make you quite disturbed. Now, once you are done doing that, the next thing is, let's go back here now. We will make this protein, go to Autodoc and then click on make macromolecule. So you're going to be making it a macromolecule. Now you can see, that we've prepared our target protein. Remember, we clicked, and then we went to Autodoc, and then we made macromolecule. For the others, we've made them ligand. So what we do is go back to Vina Wizard, click on Vina Wizard, and then click on Start. Now, the next thing you do is to select the target protein and then the ligand. So it has selected only one ligand, but remember we are working with, that's about 7 ligands. So let's go and select every one of them. I think we have their code name here. So we have, now the next thing you do is to forward, click on forward. Now once you click on forward, look at what it does. It takes you to this box, and what you're expected to do is to use the binding site you obtained and then make sure that it matches the coordinates we have here. So let's go back to that binding site. We have x as 23 point minus 23.766. So x-axis minus 23.766. We've gotten something good, and then what we do is we then forward it. Now you're also aware of the dimensions you should work with. They should not be far from each other. If you were using the paid version, you would just put in everything. But since we are using the academic version, that's why we have to do this and make sure that we get something that is very close to what we're expecting. So what are you doing here? Don't forget you are um, putting in the coordinates of your binding site, which we obtained from Discovery Studio. So we forward. Now, once you click on forward, the docking begins. And then what you're expected to do is to wait for the docking to be completed. And once it's completed, you can analyze your results.